A lot of people ask for this, so I'm happily doing the 2013 problems 4 and I believe 5 free response APBC Calc questions. So I'll go through them relatively quickly. Feel free to follow up with any questions you have. But number 1 says find all values of x on the open interval which the function has a local minimum. Now before I start the problem I do this. This is f prime of x, which reminds me that f is the integral, f double prime is the second derivative, the derivative of this. So where do we have a local minimum? Now local means we don't have to, well, we should check the endpoints or at least think about them, but I don't think they're getting into that. They're just saying where do we have a local minimum. So I immediately say where does f prime cross the x-axis? And I notice that it's at 1, 2, 3, 4, and 6. So at x equals 4, we get this kind of thing. The slope value, not the actual slope of the line, is positive, and the slope value is negative, so that's going to be a max. We want a min, so no. And then at x equals 6, we have the opposite. A negative value coming in, that's there, and a positive value coming out, that's over there. So we have a min. Now I have to answer the question carefully. Find the function that's a local minimum. Okay, there's a local minimum. It's accumulating area at the end and accumulating area at that end, so I'm going to ignore those. So at x equals 6, local minimum. And they asked me to justify, so I will actually get into that. Since slope goes from positive to negative. And that's what I would do. For B, whoops, that's a little big. It says determine the absolute minimum value. Okay, well, we're going to have a min at 6, so we check the endpoints. Check x equals 0, x equals 6, and x equals 8. Well, I'm going to go backwards. They say that f of 8 equals 4. Now we're going left, so the areas are all flipped. At 6, f of 6 equals 4 minus 7, which is negative 3. And at 0, 4 minus 7 plus 3 minus 6 minus 2, which, if I'm not mistaken, gets us to negative 8. So this one I'm very careful on how I word it. I would say, okay, determine the absolute minimum value. The absolute minimum value of f of x is negative 8 and occurs at x equals 0. Now I actually usually write it as f of x has an absolute minimum of negative 8 at x equals 0. Either one will do. So you can go either way. Running out of space a little bit here in terms of being able to see what's going on at the same time. What open intervals is both concave, down, and increasing. So we want a positive slope. We have a positive slope between 0 and 1, positive slope between 1 and 2, and a positive slope between, actually make that 1 and 3, I believe. Yeah. Between 1 and 3, and 3 and 4, and 6 and 8. Now, the only time that we have, and they want concave down, the slope of the second derivative is negative. So slope of the first derivative, slope of f prime of x negative at (0 to 1) and 3 to 4. So the question is, on what intervals concave down and increasing? All right, f of x is concave down and increasing from 0 to 1 and 3 to 4. And I have actually already explained all my reasoning right above there, so no need to put more up there. All right, D. The function is defined by blah blah blah. Find the slope of the line tangent. So I need g prime of x. G of x equals f of x cubed. So g prime of x, they're just seeing if you know chain rule. This would be the kind of problem I would definitely expect to see on this year's test. F of x squared times chain rule f prime of x. So g prime of 3 equals 3 times negative 5 halves squared times 4, which is 75. And now the one that seemed to cause more problems. I'm going to be a little tight on space here. That's okay. I'll do A down here. A. Now, big argument on the AP college blog about this. How do we show this? Here's what they said to do. If limit as x approaches 0 of f of x plus 1 equals 0, and limit as x approaches 0 of sine of x equals 0, then use L'Hopital's. So we get limit as x approaches 0, and I would actually write this out a little more clearly. I don't quite have the space. I would say ddx of the top and ddx of the bottom. F prime of x and cosine of x. And we know f prime of 0 is negative 1, and cosine of x is, cosine of 0 is 1. So we get oh, no, that's f of 0, my bad. Figure that out. Cool. So dy dx is, we get y squared 2x plus 2. But we can plug in 0 here, and we can plug in negative 1 there because of this information here. So blast it out, and you should get 2. Now the big part that I've got a lot of questions on is Euler's method. Now they did Euler's method in the answer key with y equals mx plus b. Actually, it's more point slope, but that's another story. For Euler's method, I do this: x comma y, and I totally boffed the math first time I did this, so don't worry about making mistakes. Just be careful. If you have a calculator, use it. I don't know what the rules on the new test are going to be, but I think you'll be good to go. Delta y, x comma y. No idea why that just happened. So we're starting at 0, negative 1, and delta x is 1/4 because we're going up to 1/2. We're going to have 1/4 here next time. We're going to have 1/4 here. We're going up to 1/2, and we have to do it in 2 increments. So 1/4, 1/4 gets us to 1/2. dy dx, we plug all this in. We just found in the previous step is 2. Delta y is this times this. All right, that causes a lot of confusion. I'll write it out. dy dx times delta x. That's delta x times dy dx. They cancel and we're left with dy. So that's why that works. But again, you're just going to have to get used to doing it. If it helps, write it out, but if not, just do it. Which gives us 1/2, and negative 1 plus 1/2 is negative 1/2. So we do it again, 1/4 dy dx. Actually, this is negative 1/2 now. Plug in 1/4 and negative 1/2, you should get 5/8. Multiply them, you get 5/32. You get 1/2, and negative 1/2 plus 5/32. Negative 1/2 is negative 16/32. Negative 16 plus 5 is negative 11/32. And that, I believe, is their answer. Hey, look at that, I got it right. Alright, so that's Euler's method. It's a silly little thing, you just have to flat out memorize it. Nothing else to say. I'll go with green to wrap up here. Find y equals f of x, a particular solution. A lot of you killed this, I was very impressed. So this is, you start with this equation, and you bring the y down, dy over y squared, which is actually dy y to the negative second. And then you throw the dx up on the other side, and you get 2x plus 2 dx. So when you integrate this, add 1, negative 1, divide by that, you get negative 1 over y equals x squared plus 2x plus c. Plug in your values, negative 1 over negative 1 equals 0 plus 0 plus c. C equals 1. So you are left with negative 1 over y equals x squared plus 2x plus 1. Move the y up, move the whole thing down, you will get y equals negative 1 over x squared plus 2x plus 1. You can stop there, or you can keep going and get x plus 1 squared. Either way, hope that helps. That's a lot of math. This is why you got to do a lot of problems. It's confusing stuff. A lot of you are really busting your tails. I'm very impressed. Keep at it.